So let's read through the second problem now. Chlorine gas, and again I'll remind you that I'm just having you practice writing balanced equations and practicing names, but on a quiz or test I'll just kind of give you these formulas. So let's try and write the reaction for chlorine gas can split apart into chlorine atoms. So remembering Hunkelbrief, we have Cl2 gas splitting apart into chlorine atoms, which would just be Cl gas. This reaction has an equilibrium blah blah blah. Once I hear that equilibrium word, I'm going to get a little double arrow there. And then I'm going to make sure to balance this because this is going to come into play when we are deciding these ICE tables. And then the K for this reaction looks like 1.13 times 10 to the negative 4. This would be 0.000113, a pretty little K value. This just means there's lots of reactants at equilibrium. Okay, now it says if we place 2 atms of chlorine gas initially in a flask. Now we need to remember that gases also have concentrations, and the concentrations are kind of just those pressure values, those partial pressures. So this is a ICE table problem because the question is asking for what are the equilibrium pressures of both gases. So I'm going to set up a little 2x3 table here because I have two species in this balanced equation. Now I'm going to put in my initial values here. So it says we have 2 atms of chlorine gas. So we have 2 atm here. It doesn't mention the atoms at all. When something's not mentioned, I would assume we have 0 of that. Now this problem is actually a little bit easier than that last one we did because if you're going to have an equilibrium, it means you have something. You can't have 0 here, or this wouldn't be an equilibrium. So that means this reaction has to shift to the right to make some product. Has to. So this value is going to be the positive value, and if that's going up, this has to go down. So the reactants and products always have to have opposite signs. Okay, now what's this coefficient here? Since we have a 2 there, this would be going up by 2x. And since this is a 1 here, it's going down by negative x, or minus x. So now we know the change in concentrations. What are the equilibrium concentrations? 2 minus x is just that, 2 minus x. Now 0 plus 2x is 2x. Once we have our equilibrium concentrations set up with the x values in there, we can now set them up equal to K. So remember, K equals the concentration of products divided by the concentration of reactants. The K was 0.000113. Now that's going to equal, what are our products? 2x, and then the 2x also has to be raised to the second power because we have 2 Cl's there. So 2x is the concentration at equilibrium, and it's 2x squared because of the mole ratio of 2. Now this is divided by 2 minus x. Now I said last time that there were 2 tricks you can go through. So there's 2 tricks for solving this problem. You can either take the square root or you can get rid of the minus or plus x. Now let's look at this expression here. You can always take the square root of a number. We can take a square root of 2x squared, but we can't really take a square root of 2 minus x and simplify this at all. So the square root trick is gone. That's not going to work on this one. So for this problem, here's what we're going to do, and I'll explain a little bit why we can do this. We're going to kind of just get rid of this x that's on its own. We have to leave x somewhere in this problem or we can't solve for anything, but we're going to say this one is insignificant or negligible compared to the 2. So we're going to simplify this to 0.000113 equals 2x in parentheses squared divided by 2 now, just getting rid of that x. Now here's one of the most common problems I see when we're working through this one, like this. What is 2x squared? Remember, this 2 is within the parentheses. It ends up being 4x squared. So we have to square the x, but also square that 2. So divided by 2. So now that I have this all set up, I can go 0.000113. I can multiply by 2. I can divide by 4. And I can take the square root of all of that. And the answer is 0.008, about, if we round. So 0.008. Now we need to go ahead and plug that x back into the equation. So what's 2 minus 0.008? It's about 1.99. So we see this barely changes. And then what's 2 times 0.008? If we round it'd be 0.015, but if we just keep this value, oops. And these are not molarities this time. Remember, this question was all about gases, so our answer is going to be in this pressure value. So that means at equilibrium, the final pressure of the chlorine gas is 1.99 atm, and the final pressure of the chlorine atoms is 0.016 atm. Again, it looks like it's favoring those reactants, which makes sense because this K value is so much less than 1. Okay, this is our second video, and now I want you to try that third problem before you watch the video on how to solve it.